So, good morning, everyone. Today we are participating in LeetCode weekly contest 300. So, it's started right now. So I have to do early. So, first of all, you have to you have a water dispensers that can dispense cold or warm hot water every seconds. You can either fill up 2 cups of different water, 1 cups of any types of water. You are given zero index amount. Payments, transaction, different cups of water. You are given zero index amount of the lamp. Number of seconds we are filling. 3 different cups. We are filling 2 different. For the 5 for one. So move into the draw. For the right. Yes, the 5 for 4. Yes. Zero. And Oh, one type of any type. So 4, 4. First I will try to fill 4 and 8. How I can run for all the test cases? Where is the option to use example test case? Example test case. I am getting 7 or not. I am getting 7 because every time I'm trying to fill with the maximum amount, so it's been time not exceeded. Why? 500. Oh, 500. Hmm. Finish. 5, 5. And how it's 1 here? It's not should be 1. It should be dot dot if k not empty. Okay, now it's correct. Submitting. Judging times. Oh, accepted. 1000 people has already solved these problems. Moving to the second one, which is you have a set which contains all positive integers 1 to 5. Implement the smallest infinite set class. Uh, we have to implement this class. Okay, smallest infinite set class initialize this smallest infinite set of sets to contains all positive integers. This set inside the smallest infinite set of set that contains all positive integers. Okay, int pops smallest removes and returns the smallest integers contains in a finite sets. Add back nums adds the positive numbers nums into the infinite sets if it's not already in the infinite set. Okay, if it's not in the infinite, then it will add. So we have to implement this class smallest slices. So add is adding to output is null because it's already added. Pause pause smallest will if 1 2 3. Okay, then again he added 1. Okay, so we have to implement this class use 100 cons were made. So 100 cons were made and it can be easily implemented through the set function. As it initializes all the influence I equals to 1 to I equals to 1 and 6 I Christmas restore insert right. Okay, pop back not empty this is not empty then it will use this and return start no, sorry return answer. What's this? There is only one example. I have to improve my. If I use unordered set, it will not be ordered. So there are 1000 calls. 1000 calls means of pop and add means we can remove 1000 elements. So it's better we use 5 here or 4 because if we are making 1000 calls, then we are removing 1000 this type of elements. Some accepted. Moving to the flower, you are given two strings start and target, both of length, and each string consists only of characters L, R, and dash, where characters L and R represents pieces where a piece L can move to left only if there is a blank space directly. Okay, the character L represents the pieces where the L piece can move to left if there is a blank space directly to the to its left. The piece R can move right if a blank space directly in the right. A character that represents a blank space can occupied by any L and R pieces. Return to if it's possible to obtain the string target by moving the piece of the strings any number of times, otherwise false. Okay, we have to just check if it's we have to check if it's a substring or not. Okay, no. We have to check if it's target or not. First time we are going to shift all the R's on that side. So what's the size of that size is 10 about 9. So for each R we are going to count the how many strings it have left side. Then R command is after that no fish can move anymore. So it's impossible to form these strings. Okay, and for these strings false, why it's false? The target this one R can move these sides and the piece in the string starts can move only to the right. So the right can only move to the right and the left can only move to the left side. So we will first separate them all, and in, in also the left one uh, I will try to separate for the. So what I'm trying to do is that every arc can move to its right and every left moves to its most left. So what I'm going to do is there's we will just we cannot also make this a sequence count. R can only move to the right. So for the right one, what we can do is that we can check mm, mm, this R can never move to the left. So for every first one, we will try to move. If I separate them as moving L to the left and R to the right, but if there is L and there is no L, there is L on this side and R on this. Means if there is the difference of gap between L and R should be first I'm trying to check the subsequence. Okay, the subsequence matches. Then the for if the subsequence matches, then for every uh, if the L start matching, L started matching, then the gaps can the gaps in between them, we can only change the target sum. Started matching, so 76% yes, ideal array at 0 and centimeters ARR of length and is considered ideal if the following condition holds. Index the 0 index integers array ARR of length and considered ideal allows ARR the value of from 1 to next value. Every ARR is visible by this one. For the first strings, targets L and R, L here and R here. So if they have gap target, we have to move the target. We have to move the target one. We can move. So hmm, we can solve this by making index array. Okay. We have to obtain the target sum. We have to obtain the target by making else scenario presented where the L can move to left only if the blank space is. So starting and target. Uh, this they have to be same size. They have to be of same size. So I started trying to match this. Otherwise, time to switch. Then, if the target is dash, if the target is dash, the target of y is equals to dash. It is if the target is dash, it is not possible. So, if it is equals to if the target is dash, is equals to right, it is not possible. If the target is left, if the target is sorry, S is here, the target is left, and the topmost index, and dot erase I, R dot erase I is in the left and right file. If the target is left, and the target is right here. If it's left, then we will check if the first index. If it's left, then no R should be present on that side. False. present on backside. Yes, I will not present on the backside. I have to check the first upcoming index of this is okay. S of I is L. S of I is L. How it's possible? The S of is plus one. And S L here. If it's L here, then we have not shifted to the left side. So we have to just return false. If it slides, we can target is L. And also check for the L index. Auto upper one I कोई और पीछे नहीं है, कोई और पीछे नहीं है, कोई और पीछे नहीं है, कोई और जो पीछे नहीं है, तो जो कोई और पीछे नहीं है, तो ऐसे ऐसे You're fired. Instead of going back, say, टारगेट एल मांगा तो उसको एल चाहिए। अगर एस ऑफ आई मेरा कैश है, एस मेरा आर है, तो आराम से रिटर्न फॉल्स, क्योंकि एल यहाँ पे है ही नहीं मेरे पास। Finally accepted. I suffered a lot to solve this problem. Okay, now only 150 suggestions. So try to move it. Try to solve this after the contest. So how much time left for us? Only 11 minutes. So moving to the solution part. So now the contest is been over. So we are going to discuss the first three of these problems. So moving to the first one, second, and third. So in the first problem, we simply say that we have given three cups. So we have given three cups, amount one, amount two, having, and we have to fill them with amount one, with amount zero, one, and two. Those three cups. And in 1 second, we can fill two cups with the different types, and otherwise we can fill the one cup with any type. Okay, there are two possibles. So moving to the moving my OneNote. So we have cup 1, cup 2, and cup 3. We have to fill them with amount A1, A2, A3. Right. So operations we can do is first we can fill two cups different type or one cup of same type. So according to the ingredient, it's always benefits us to fill the cup with the highest amount filled. Means let's if it will be A1 greater than A2, A1, A1, wait, is it A1 greater than A2, greater than A3. So here we can, it's always beneficial to fill these two cups until it becomes less than or equals to A3. Through this, we can always fill the cup with the maximum. So it will require less steps. Therefore, what I'm doing in this problem is that simply filling these cups always with the maximum of the top twos, and here the amount is 100, so we can simply run the brute force. So simply I have taken a priority queue. In the priority queue, it will store in the priority queue, it will stores in a descending order, means the amount which is greater amount always in the top of the priority queue data structure. So here I have inserted if the x is greater than or equals to qi, so I'm inserting that in my queue, and if the size of the queue is greater than 2, means we in each second we try to fill with the two different cups. So here the same what I am doing, taking out the my two topmost greater cups and answer plus plus once again, and each time decreasing them, and if the T1 and T2 is still greater than 0, then again inserting them into my queue. So this way we always get the first two of the tops which are always greater in our queue. And if the size is less than, if our queue is not empty, means the size is less less than size is less than 2, therefore means here the size will be 1, because here we have erased all the size greater than equals to 2. So for the one size, I can only perform the single last operations, which is this 1 cup of water to any type. So we not have any other option to fill the in 2 cups. So simply adding the amount of water that we left in the single cup, simply added and returned the answer. So moving to the second problem. Here it's a simple set problem. We have given positive integers. What the question says that we have to implement the smallest infinite set class. This class first this class is class with all the positive integers, and if we call the pop smallest, it will return the smallest integer in the infinite set. Add back to add the class. So what's given in this problem here? We have given a class smallest possible, and which having integers from 1 2 3 up to infinite, we have said. And second operation is doing in as pop smallest. In the pop smallest, we have to return the smallest integers in our set. Okay, and in the third operation, add we are adding a number num in our set. So what's for the key hint in this problem is that they have said the at most 1000 calls will be made in total in the total of pop, smallest and add back. So they have given at most we can only calls 100 calls. So if we calling 100 times, so we does not have to need to store infinite number of positive elements in our set. Our work only be only can only done in up to 1000 natural numbers, because each times we are calling a smallest, we can go up to 1000 and return that smallest. So that's the same thing I have done in this problem. For the safety purpose, I have taken 1 You can also take it 1 It's also going to be because because we are calling only 1000 elements in our set. So first I'm using my set data structure in C++, which store the unique elements. Also pop smallest. Here here I'm storing answer if our set is not empty. So smallest element will be begin element of the set. So answer equals to s dot begin. And now I'm erasing these elements from the set and returning it our answer. And in the add back, I'm simply inserting in our set. So that's all for this second problems. Moving to the third one. This one has required me more times, also decrease my rating further. I have done too much case in these problems. So wait, as I have written too much case. So first thing I'm going to explain this problem. We have given a string as, means let it be the string as starting string, and the target will be t that we have to reach in the end. And we can we have to change the start equals to the target and both of length and okay. Each string consists of only letters L, R, and dash. So the operation we can do is that if we have L, so if we have L, if so, we have said that if we have L, if we have L, then we can only shift it to the left if there is dash present on the left side. And if we have R, then we can only shift it to the right side if in our string dash is present this side. If and L, if the dash is present this side, means R can move to this position, this position, this position, and L is moved to this position, this position, this position, in this way. And it's the two operation that we have given here. And the character dash represents the blank space occupied by L and R. So we have to return true if it's possible to change the string start to the target by any number of times moves. So what I have done in that, so so it's basically based on the three cases on the values. So uh, first I'm going to explain some cases. So we have to change s to the t. So first, let only focus on the string t. If the target here If the target is dash, then three cases for the S are S. If S is dash, then continue. They are same. No need to change. If the S is if the S is R, we can simply insert. We can simply insert in our stack and stack count the R that we have present. Stack equals to 1. So here we can also continue. Means it's the movable position. But if here we have present, if here we have present L, means the S of I is L and S of T I is dash. And suppose that for the all 0 to I minus 1 we have set our string, means for the 0 to S1 S of I equals to T of I. Okay, they all are S of I minus 1 T of I minus 1 for from 0 to I minus 1 they are same. And for the ith index we are saying that if the Ti is dash and the Si is L, then it's never possible, it never possible to move this L to the left side because we have already matched all the same strings. So here we have to return the false. So also let take if the T of I equals to L this time. This time this is L. So we require L. So here what we can do is that, so here the false case exists if we have in our stack that we have stored the count of I. If our stack of R not equals to 0, then again this will going to be false because it does not forming a subsequence because R is already present in our backside. So we cannot, we have to first make this 0 and we cannot make this 0 because here we require L this times, and in our stack in the previous backside, in the backside we have already stored the R. Since this is not equals to 0, then return, here it also return false. So the second, if the stack of R equals to 0, then the backside cases are clear for this, and here we require R. So if S of, also if the S of I this time equals to R, it's again not possible because we require L distance and here we have R. So we can simply put R to the right side, but there is no L present in range from I to any other dash side that we are requiring. So for the true case, and for the third case, we require L this side. So it's possible that S will be option. So if the S of I dash, now we have to check if the S of I dash. So the most closest L in the left side is L or not. L is present in the left side or not. Simply, if in this case exists RL in the right side, in the right side string, then again it's not possible because L can never be jumps to this R to come in this position because R of it are occupying this place in the left side of L. So again here returning false, and if this case is just L and R, then simply we can move L to the this side and swap this position. Then this will be L and this will be dash in the new string. Therefore here also then this case will be continue. So uh, I have covered T equals to dash T equals to for T equals T of I equals to R, we cannot see in the upcoming I plus 1 strings any r is present, because r can never be moved to the left side. So simply I'm checking that in our stack, if in our stack r is present, so simply take this r, then count of r will be decreased by 1, and we have cleared this case. Otherwise return false, because it's never possible to have s of I equals to t of I equals to r in this place if the s of I not equals to r. So also we have to check if the s of I this place is not equals to l, because we cannot also move to the left side. Simply what I have done in this problem, simply the case that I have written. First I am inserting the indexes of the first I am say indexes of the L and R in the starting string. So here storing the stack, the backward R that we are going to encounter in our problems. So first I'm iterating a loop. So we will come to in the will be soon. First see this. If the t of I is dash, simply s of I, no, simply s of I. If the t of I and s of I equals to r, then the case we have discussed is pushing this in our stack, and if the s of I is not equals to l, then returning, if s of I equals to l means it is not, because it is not possible to move this l in the backside, because we have already matched the 0 to I minus 1 characters, so returning false here. And third case I have not written that both these are same, because it does not have any value to write here. So here if the t of I is equals to l, then there are three cases of the s. If s of I equals to dash, then I'm simply taking the closest l which are present, so closest l and the closest r, so taking the lower one with the I. So if no l is present means ideal is equals to l dot n, means there is no l is present in our right side, so simply returning false. So if the idr, and now I'm writing in the idr, if r is also present in right side and l is also present in the our right side, so simply we have to check if our uh, l is closest than the r. So simply I'm doing, if l is closest then our, I simply putting at this index dash and erasing this ideal, means in the right side we have removed that l. So otherwise if they are same or greater than equal to, then returning false. If r is not present, then we have to only do for this l, because we does not have any boundary obstacles for our l to come in the left side, because no r is present on this side. And the second one, if s of I not equals to l, means they have to same. If s of I equals here, then means the s of I here equals to r. So if it's r, again returning false, because we cannot set to the, because mm, here we require l and we have condition of r. So in the third case, if the s of I is r, simply we have to take, we are checking if the current position is l, then returning false, because it's not possible again to move this l in the back side of I minus 1. Otherwise, if the s of I is dash, then simply what I'm doing is, in our stack, if there is any r already present in our past, that I am storing in Ri, simply if it's empty returning false. Otherwise if it's not empty means I'm popping, means decrementing that Ri. So now moving to this, and for the all the i's, if our Ri is not empty, so if t of I is equals to l and our previous I minus ones are not set because R is also in our stack. So simply we have to return false because it's not making that same subsequence that of S and TR of different subsequence it's going to be create. And here if the T of I equals to R, so we can do the case that if S of I equals to L, returning false because the current index can have to be empty to replace this Ri. So Ri is now Ti is R. So Ti is now going to be replaced by the previous stack elements. So simply pushing. And here if the current Si is still R, means the backside is also R is present that we have shifted here and the current position is still we have this I position we have R. The cases, the example that it have given in this one, here the R comma R and RR. So this first example, so again pushing in our stack, and here what I'm erasing the index of the Ri that we have encountered in this position. So that's all for the this third problems. Now we will meet in the next weekly contest. Okay, have a good day and bye. 5,000 again.